Hello and welcome to Lexx Education, the economy science podcast with me, a man called Ron, and Laura, who's not here. She's in Yorkshire, and she does not have the internet to either attach the intros, outros that we already recorded to this episode, nor upload the episode, as she usually does. So I, Ron, have gotten out of bed with a sleeping girlfriend of the podcast studio in the next room of a small flat to introduce the episode. It's the second episode of the higher tier biology exam. It's we're really sinking into the desperation. Now that we reach and we really pick up the rock and look at the word lice, see the difference between foundation and higher tier. Again, apologies for the sound quality. We'll make apologies for sound quality right now. Not the most professional episode we've done. The sound quality does get better towards the end. And that's about it. I'm trying to keep it brief because I was literally with my head down going to sleep before I got up to do this. Love you guys. See you at the end.
Oh no, we're on to question 4. Look at that.
Whoa.
Question 4.
How
1
many
hour
questions
7.
are there?
7. We've got 1 hour and 7 minutes left.
All right. We still got to go back to that aseptic question, though.
Yeah, I've labelled it orange
I
on
hope
my
it
sheet.
occurs
so
to
we
me
can
what the
find
answer
it.
to that is as we do the rest of it.
I can't even remember what the question was, to
There's
be
something
honest.
about making things aseptic.
Oh yeah, aseptic techniques. Laura, all living organisms respire. 4.1. What is the chemical equation for aerobic respiration?
Oh, Christ on a bike.
And then you have 4 options there.
Jesus, and they're all just combinations of the same stuff, really. Wait, let me think about this. Okay, so what is it? It's water and oxygen goes in. No, water and carbon dioxide goes in, and oxygen and sugar comes out. So it must be 6H2O plus 6CO2 turns into 6O2 plus C6H12O6. It's that one, Ron.
Water and carbon dioxide goes in.
Yes. That's right. Yes. Yeah? Why are you looking at me like that?
Oxygen and sugar come out.
Yeah, I'm pretty no. Wait. Aerobic.
4.2.
Wait.
Name the substance.
No! That's photosynthesis I'm talking about. Is that aerobic respiration? Oh, Christ, I don't fucking know anything! Yeah, I don't care.
All living organisms respire.
So is that not right?
I'm just going to say a few things. All living organisms respire.
Yeah.
Are all living organisms taking in carbon dioxide all the time and turning them into sugar?
No.
Do you want to rethink?
What is the chemical equation for aerobic respiration?
What do you need to breathe?
Oxygen.
Dumbins? Yeah.
But I don't breathe sugar or carbon dioxide. Do I? Do I breathe carbon dioxide too?
You breathe it out.
But the only ones they're going in with oxygen is either carbon dioxide or sugar.
Yeah, where do you get sugar from?
Chocolate?
You eat it. So you take in oxygen and sugar.
Oh, okay. Bottom one then, please.
Yeah, that's counting as your
No,
health,
it's
though.
not, because I didn't know.
is.
No, that was a nodding under the ocean one.
Nodding under the ocean?
Yeah, I didn't actually ask you to. You chose to.
Are you referring to Aladdin?
Yeah.
That's insane. Anywho. Right, name the subcellular structures where aerobic respiration takes place.
What? Subcellular. Inside a cell. structures where aerobic respiration takes place.
This you should know.
Why should I know
Because
this?
we've gone through this. I think this might be biology lesson 1.
Ribosomes.
While you think about this, I'm going to wee.
Ribosomes.
While you think about this, I'm going to wee.
What's in a cell? Christ.
Have you had a little think?
Mitochondria.
Shall I write that down?
Yes, please, Ron.
Where did you get that from?
My butt.
Did you look it up?
No. Oh, that would have been smart. I think that's right then.
Yes, it is. Energy is released in respiration. Give 2 uses of the energy released in respiration.
Movement. And growth.
Movement and growth.
Sure.
Okay.
I don't know, Ron.
Question 4.4.
Thinking? Digestion. I don't know. Oh, I hate this so much.
Question 4.4. Describe 2 differences between aerobic and anaerobic respiration in humans. Do not refer to oxygen in your answer.
But that was the difference, isn't it?
That might suggest it's not the only difference.
Anaerobic respiration produces lactic acid.
Okay, and another one? This is a weird thing that we do, isn't it?
Yeah. I feel genuinely physically angry and cross and sad. Anaerobic respiration. Oh, I should say aerobic respiration does not produce lactic acid. That's a difference. You know?
Yeah.
Okay. Number 2, aerobic respiration can be done indefinitely, whereas anaerobic respiration leads to muscle fatigue and sickness.
Muscle fatigue and sickness, did you say?
Yeah, it makes you feel sick because the lactic acid has to be processed away and you have to digest it, and so it makes you feel sick. That's why you sometimes feel sick when you've been running for a long time or something.
Question 4.5. What are the 2 products of anaerobic respiration in plants?
Well, I don't fucking know. We haven't even talked about any of this. Jesus H. Bum. I don't know.
There are options.
Yeah. Well, I don't have a clue, though. I've never been a plant. Anaerobic respiration in plant cells?
There are some that you
I
can
didn't know that they did anaerobic respiration. Do they make lactic acid? Probably not. Let's say ethanol. Maybe that's how you get potato vodka. Ethanol and...
It's proper cold now.
Yeah. I moved my little washing heater thing into the roof. I can't have it on while we're recording because it's too noisy. Ethanol and carbon dioxide. Fizzy wine. Oh, I wish I had wine. Oh, I started that wine I got from the food fair this weekend last night, Ron. It's bloody delicious.
Nice.
Yeah.
My goat's in the freezer.
Ooh.
I'm going to make a goat vindaloo.
That freezer really gets your goat.
There's a fucking goat in there.
Fucking damn it. Oh, fucking damn it.
A scientist investigated respiration and photosynthesis using some pondweed and a pond snail. Figure 6 shows the apparatus used.
Ponds was such a big deal in science at primary school, weren't they?
I always thought that was just because of the school we went to and there was a big pond, but it seems that no, all schools were fixated on the pond.
The nature area. Do you think that nature area is still there? You didn't even go to the same primary school as me.
I did,
Did you?
for some of it.
I thought you went to Troll.
I went to 2 different primary schools.
Yeah,
Where was the
fucked up
nature
then.
area?
Over, you know the temporary huts that were still there?
Yeah.
Yeah.
Yeah. And probably still are, let's be real.
Ooh, what a well-funded school we went to. You know where they were like into the 2 corners of the junior playground? No, the infant playground.
Mm.
So you had like the actual building along one side,
Yeah,
and then
yeah.
the other. It was in the corner where those 2 met.
I don't remember that. Anyway, Laura, do you want to describe figure 6?
Sigafix is Jesus. What is this? So we've got a test tube. It's it's a boiling tube. I think those are wider than test tubes,
They are
weren't
wider.
they? Yeah. It's got some water in it. It's also got a pondweed, pond water, and some pond snail in there. Then it's got a cork in it that's got a carbon dioxide probe going through the bung. It's actually a bung in Science World, I think.
There's a bung in
And
Science
then-
World.
The carbon dioxide probe goes into a data logger.
The apparatus was left in a well-lit room for 5 days. The data logger recorded the concentration of carbon dioxide continuously. After 5 days, the scientists completely covered the boiling tube with black paper. The data logger continued to record the concentration of carbon dioxide. Figure 6 shows the concentration of carbon dioxide inside the boiling tube over 15 days. This seems quite cruel on the snail.
It does.
It's got...
Oh well, his own fault for being obese.
So for 5 days, it's
Suck
level
it, Snailio.
at 5 carbon dioxides in arbitrary units, and then it starts to rise. There's a big jump between 8 and 9, and then from 10 it levels off for a bit and then starts to rise again. Laura, explain, for 4.6, for 2 marks, explain why the concentration of carbon dioxide in the tube stayed the same between day 0 and day 5.
There was an equilibrium of carbon dioxide being produced, presumably by the snail, and absorbed by the pondweed.
Sorry, say that again. There was equilibrium between the carbon dioxide being produced presumably by the snail and...
The being absorbed by the pondweed.
Suggest why the concentration of carbon dioxide increased between day 5 and day 10.
Because the black paper blocked the light coming into the boiling tube, meaning the pondweed could not photosynthesize and therefore did not absorb any carbon dioxide.
Okay. .8. On day 10...
No!
Yeah, on day 10, the pond snail died.
I have so many ethical issues with this science paper.
Explain why the death of the pond snail caused the concentration of carbon dioxide to increase after day 10.
I don't know.
For 3 marks.
Fucking all this just for nothing. Maybe the decomposition of the snail's body would release stored carbon dioxide within the cells of the snail.
Decomposition of the snail's body released stored carbon dioxide where?
From within the snail's cells. Not cells, but tissues.
Not cells, tissues.
Yeah, I don't know.
The decomposition of the snail's body released stored carbon dioxide from within the snail's tissues.
Yeah, I don't really know how to get 3 marks out of that, but Yeah, that's all I've got.
Okay. Question 5, Laura. Question 5 in 50 minutes. Amylase is an enzyme that breaks down starch.
Now, finally, we're doing a bit that I truly believe we discussed at some point.
Ow. Amylase is a polymer of smaller molecules. Name the type of smaller molecule.
Oh, I don't know. Enzymes. Amylase is an enzyme. Enzymes are the things that end in lase. I'm going to say an enzyme, Ron. No, it
I'm just
already
going to
says
read the beginning of question 5 again. Amylase is an enzyme that breaks down starch.
Oh. Christ.
I'm glad that you really up front admitted that we've discussed this, we've gone through it.
Amino acid.
Final answer?
Yeah, it's the only other thing that's percolating in my brain that was in connection to these things.
Name the 3 parts of the human digestive system that produce amylase.
The stomach. The intestines. And the liver.
Final answer?
No, yes.
Digestive
Kidneys.
system.
Is the liver not in the digestive system? The bowel. Let's change that to bowel.
The bowel.
Is that a thing, or is that a name for a broader spectrum of things? What else is in your digestive system? Pancreas? No. Kidneys? I don't really know what they are. What have we got? Maybe large and small intestines. That could be fun. Stomach. Intestines. What else is there? The kidneys. Let's say... No, that's about blood, isn't it? Kidneys. Liver's piss? Is liver piss? Pancreas is a sugar thing. What else is in there? What other organs have you got? 3 parts of the human digestive system. Maybe saliva. Let's say saliva.
Which one are you getting rid of? Stomach, intestines, or bowel?
Bowels.
So you think your saliva produces amylase?
All right, maybe your mouth. Mouth? Maybe your saliva is amylase. Mouth.
You want to say mouth?
Where does saliva come from?
You want to swap bowel for mouth?
We've definitely never talked about this, Ron. So I don't know. So it's all guesswork, isn't it? Where does saliva come from? Under your tongue? It just oozes out your mouth, doesn't it? Does it come up your throat? Where does saliva come from, Ron? Just oozes out your mouth, right? Ron!
Yeah, do you want your help on this one?
Yeah.
Okay, right. So
Wait, how are there 2 marks for 3 answers?
you get 2 marks for all 3 correct, 1 mark for 2 correct. You've so far got 0 correct.
Oh, I don't want my help then. Fuck it. It's a lost cause because I don't know.
If it helps, you're close.
Oh, God, it doesn't help, though, because I couldn't even think of 3 organs. How can I be close and have 0?
Well, because you're close with saliva. There is amylase in your saliva, but it's not made by the saliva, which is what...
Well, I don't know where saliva comes from.
If you had to name it, where...
Mouth!
What part of your mouth? What's the word for something in your body that makes stuff?
Organ.
No, an organ's a collection of tissues. There's a
Tonsils, is that what... No, because people who have tonsillectomy still have trouble.
Try that. People that have tonsils. No.
Imagine that, you had to spritz it with a little, like, plant mister to
What's
keep
the
your
word
mouth
for
open.
something in your body that secretes things?
Glands?
Yeah.
Saliva glands.
Salivary glands. Yes, okay, so we'll swap out mouth for that, maybe.
Okay, saliva
Now-
glands.
You mentioned something, and you said, that's a sugar thing. I'm going to refer you to some previous
Pancreas.
information. Amylase is an enzyme that breaks down starch. What is starch made out of?
Sugar. Pancreas.
Okay, do you want to swap out stomach or intestines? I've already told you they're both wrong. So,
I'll take out stomach, please,
okay.
for pancreas.
Now, intestines, Laura. Do you think amylase breaks down starch? Starch is made out of glucose. Glucose is used in respiration, possibly the most important thing that your body does. Okay? We're all about getting it out of places. We're literally breaking it down in the mouth so that we can get onto this glucose as quick
Lungs.
as possible. What the fuck are you talking about? Why would there be starch in your lungs?
Red blood cells.
Let me finish.
Okay.
We're trying to get it as quick as possible. Do you think that we're going to produce amylase throughout our entire intestines?
Yeah, just in case we've got to rinse that last bit out.
Why do you always do this? Why do you
No,
let
Ron,
me
no.
lead you right up to the door and then you
No.
slam it in your own face?
No, Ron, there would be no amylase in the intestines.
That's not what I'm saying either, because
No,
the intestine is where
yes.
the intestines are where maybe you didn't know this, but the intestines are where we extract nutrients from the food that we're eating.
Yeah.
So are we going to do that? Bearing in mind that glucose is this important, are we going to do it like in your butt right before you shit it out, or are we going to do it as soon as possible?
Soon as possible. Throat glands.
I'm talking about your fucking intestines. You stupid.
I know, but you're telling me it's not intestines.
No, I'm not. Which
So
bit of
is
your
it-
intestines comes first?
I don't know. Small.
You tell me, and I will
I don't
write it down.
know.
But that's all the help that you're getting.
Ron, you're talking to a person who used to think that big poos came out your big intestine and small ones came out your small intestine.
Yeah, you're
And-
thick. We know.
Small comes first.
You want to say small intestines?
Yeah.
Okay. Final answer?
I don't know, Ron. I've lost the will to live.
That's your help gone. Right.
I get another one though. I get 2 helps.
You've had 2 helps.
I haven't. I've had 1 help.
You've had 2
And a
helps.
nod under the ocean.
5.3, Laura. Explain how amylase breaks down starch.
shitting-
Answer in terms of the lock and key theory.
Oh, God!
42 minutes.
Fucking 41 minutes too long.
That means we've been doing this for an hour.
Oh, we've been doing this for an hour and a half because of all that bump at the beginning. Oh, I've dribbled all over my desk. Look at all this amylase. I need to clean up.
Do you remember when I got you to chew that bread?
Yeah!
That was about amylase being in your mouth.
Oh, it started to taste like glue.
Answer the question, Laura.
Trying. Amylase has an active
Laura, we're only
site.
halfway through in terms of pages. So you
I'm
need
trying to
pick it up.
fucking answer them! Write it down!
Right, say it again.
Amylase has an active site.
3 marks. Let's go.
That when starch comes into contact with amylase, it fits into. This is sometimes described as a lock and key theory because the key fits the lock in the same way that starch fits into amylase to be broken down. And then the breaking down happens.
Hang on, sorry. In the same way that starch fits
And
into...
the-
Hang on.
No,
It's into
I
your
shan't.
amylase.
The
And the
amylase
breaking down happens. And the amylase...
is reduced to its component parts. No, the starch, sorry, is reduced to its component parts. I am up here, darling.
Amylase has an active site. When starch comes into contact with amylase, it fits into. This is described as a lock and key theory because a key fits into a lock in the same way that starch fits into amylase, and the breaking down happens, and the starch is reduced to its component parts.
I hate this so much.
We should have done higher tier first. This is gold.
This is horrible.
Okay, we done with that one?
Yeah.
1.4. I think we should pick up the pace. A student investigated the effects of temperature on the activity of amylase. Figure 8 shows the apparatus used. We've got 2 test tubes sitting in water, starch solution. Well, so starch solution in one, amylase solution in the other. The water's at 5 degrees. This is the method used. Set up the apparatus as shown in figure 8. After 5 minutes, pour the starch solution into the amylase solution and mix. Remove 1 drop of the starch amylase mixture and place onto a spotting tile. Immediately add 2 drops of iodine solution to the starch amylase mixture on the spotting tile. Record the colour of the iodine solution added to the starch amylase mixture. Repeat steps 3 to 5 every minute until the iodine solution stays yellow-brown. Repeat steps 1 to 6 using water at different temperatures. Laura, name for me now the 2 control variables.
The temperature of the water. And the time. No?
What's
Don't
a
like that?
control variable?
Things that you're keeping the same. After 5 minutes. The amount of iodine? I don't know.
Read step 7.
Oh. The water temperature's changing.
Yes.
So it's not a control.
No. You could call it the opposite.
I don't want to be here anymore. I'm so hungry.
We've got 38 minutes.
I'm so hungry, Ron. I'm hungry, Mother. I really am.
Right, this is an easy one. You're good at control variables. Come on. What is staying the same, Laura? What is staying the same? Answer me. What is staying the same?
The volumes.
Volumes of what?
Starch and amylase.
All right. 5.5. Why?
But we had to do 2 controls.
Yeah, you said time and you said the volumes of starch and amylase. Why did the even volumes of starch and amylase? That's already 2. Why did the student leave the starch solution and amylase solution for 5 minutes before mixing them?
To let them adjust to the temperature of the water.
Okay.
Goldfish logic.
5.6.
That was such a big part of my childhood, letting goldfish acclimatise to the tank.
Oh, cleaning out those fucking tanks all the time.
Yeah.
People don't really have fish anymore, do they?
We had fish until we moved here.
Yeah.
They kept
Yeah, but
eating
they
each
made
other
you
though.
really
They were
sad.
They did. They were a lot of work and they just died for pastime.
Anyway, table 3 shows the results of the investigation. Table 3, temperature. We've got temperature going up 5, 20, 35 in intervals of 15. And then you've got the time taken until iodine solution stays yellow-brown.
Ron.
What conclusions
Ron.
Yeah.
What does it mean when the iodine goes yellow-brown?
You should know that.
Why should I know that?
Because we've talked about it extensively.
Does it mean that there is no sugar left?
What happens when you mix amylase and starch?
The amylase digests the starch.
Okay, so what do you think that the iodine could be an indicator for?
No starch. More starch. No starch.
What do you
Sugar?
think? What do you think?
Glucose. Is it glucose?
Iodine. I'll give you this for free. Iodine's black when you first drop it in there, and then at some point it goes yellow-brown. We can work that out from the paper, can't we?
Yeah.
So what do you think going yellow-brown means? Think.
Means it found something in there that it liked.
You literally just said it.
Is it glucose, Ron?
No,
Is it starch, Ron?
it's black when it's starch.
Is it? There's no starch, Ron.
Yes, when it
Okay.
becomes yellow-brown, there's no starch.
Okay.
What conclusion can be made about the effect of temperature on amylase activity between 20 and 65?
Imagine you sat in your GCSE and one student is having this much conversation with the teacher.
And the teacher's just being that rude to you. Think.
Right. What conclusion can be made about the effect of temperature on amylase activity between 20 and
Real
65
quick,
degrees?
this one.
Okay. As the temperature increases, the amylase breaks down the starch more efficiently.
What does more efficiently mean?
Not yellow-brown.
All right, we're leaving it at that.
With more efficiency. Fine. Oh, Christ on a bicycle bell.
Explain the results at 5 degrees and 80 degrees, Laura, for 5 marks.
At 5 degrees, there is no starch present in the solution
Why would that be the case?
because it didn't become yellow-brown.
But there was starch in the experiment, wasn't there? There was a starch solution that they mixed together, wasn't there?
Well, the
Wasn't there?
amylase has eaten it all. Hasn't it?
Instantly? No, because it doesn't become yellow-brown.
I thought it became yellow-brown when there was no starch.
Exactly, and it isn't becoming yellow. It did not become yellow-brown. It stays the other colour.
So,
Think.
at 5 degrees, there is still starch in the mixture.
Sorry, I unplugged my headphones for a second by accident in my rage. What did you say?
At 5 degrees, there is still starch present after 5 minutes because the amylase has not been heated sufficiently to have the energy to have catalyzed all of that starch in that time. Then I reckon at 80 degrees, there is still starch present because the amylase has got cooked and it can't function at that temperature. So it's too hot for the amylase to break down the starch. Or it's baked the starch into a cake like popcorn. I don't know.
Okay, you've not completely understood the experiment, but let's move on. The student investigated the effect of temperature on amylase activity. Describe how the student could extend the investigation to determine the effect of a different factor on amylase activity.
What? What was the question?
You're going to read it for yourself after I read it, so why don't you read it?
The student investigated the effect of temperature on amylase activity. Yeah. Describe how the student could extend the investigation to determine the effect of a different factor on amylase activity. They could do the experiment, but instead of changing the temperature of the water, they could increase or decrease the amount of light that the beaker was exposed to using different lamps. Please stop laughing.
Question number 6. Figure 9 shows a cross-section of a leaf with different cells labelled A, B, C and D. Laura, which cell is most transparent?
I'm going to say A, which is the cell wall.
What do you mean it's the cell wall? What do you mean it's the cell wall? This is a leaf.
Is the leaf wall then? A, Ron, A.
Alright. Which cell structure in a least mesophyll cell is not found in a root hair cell?
Chloroplasts.
Plants lose water through their leaves. Name the cells in...
Stomata!
Name the cells in a leaf that control the rate of water loss.
Stomata! I think I know that one, Ron. I got one. No?
Water
Is that not right?
Water is...
Oh, Ron! Is that not right? Ron? Isn't it? That's the buttholes, wasn't it? The buttholes? Is that not right?
Stomata is the butthole. But if you were to say what keeps a fart in, it might be sort of your sphincter rather than the hole.
So, sphincter.
But no, because they're not really buttholes, are they?
Oh, fuck.
You have another guess, or should we move on?
Oh,
I don't
I
think
thought
you know
it was stomata and I was really happy.
Stomata is so close that the mark scheme says ignore stomata.
That's horrible. Oh.
Laura, stop playing with those scissors. We're professionals.
Well, actually, I'm cutting up the doodle that you did while you were doing your day job, so...
Angopus! I did some good doodles when I was up there. It's Triple Wendy's.
Yeah. Actually, I think I drew on Triple Wendy today. Oh no, she's on the back.
Triple Wendy.
That's 4.
Yeah. Triple Wendy's an enigma. Anyway, water is taken in by the roots and transported up the plant and lost from the leaves. Which scientific term describes this movement of water?
Active transport. Osmosis? Active transport.
Active transport, is that what we're saying?
Yeah. God, I feel bad about this.
26 minutes. Which change would decrease the rate of water loss from a plant's leaf? Increase humidity, increase light intensity, increase density of stomata, increase temperature.
Which change would decrease the rate of water loss? Increased humidity.
Compare the structure and function of xylem tissue and phloem tissue for 6 marks.
Fuck off! Oh, I should have looked harder at that sign at the Wild Place project, Ron.
You should have.
That had gobum and phloem in it. Well, I can't remember which way round they go, so I might as well just piss this off a balcony right now. Because you probably don't get any marks for saying, like, one of them has connecting cells with a sort of perforating connection to them, which allows fluid to pass between the two easily. And one's just like a straw. One goes up, one goes down. One's for water.
You don't think it's worth even taking a guess?
I can't remember which way round they go, Ron.
It's 50, isn't it?
Yeah, but then I've got to put in loads of effort and I'll probably get it wrong. So I'd rather put in no effort and get it wrong.
So are we skipping this one?
Well, no, I'm giving you answers here.
All right, I'll tell you now. You won't get any marks for one of them, and one of them this and one of them that.
Well, that's stupid because I'm proving I kind of know it. I just can't remember the words.
No, that's not stupid.
Ugh.
If it was a geography exam and you were asked to compare France and Spain, and you're just like, well, one of them likes tapas and the other one likes garlic, you wouldn't get that. And if
You
went
would
to...
if the examiner could just apply a small amount of common sense to your answer.
Oh, this is on the examiner, is it?
Yes, it is. Phloem has tubes.
Why don't we do some other ones and come back to this one if we have time?
Phloem has the perforated joints of cells, like a little centipede. We simply have to have snacks for the exams. I don't care how unprofessional it is. I can't do this without snacks. My tummy is sad and fizzy, and my eyes want to close, and I'm cold.
Phloem has tubes. Phloem has the perforated joins of cells, like a little centipede.
Xylem has ladders for sugar, going up and down. Phloem only goes one way. Structural more in the xylem. I don't know. That's it. 6 marks.
Phloem has
Don't
tubes.
read it back to me, don't you
Phloem
dare.
has the
Don't you dare read
perforated
it back to me.
Of cells like a little centipede. Xylem has ladders for sugar going up and down. Phloem only goes one way. Structural more in xylem.
Tummy's sad.
7.1. We're on to the last question though, Laura. Figure 10. Oh no, we're still on question 6 actually. Here we go. Laura, there's a graph on page 26.
I like a graph.
Figure 10 shows the volume of water lost from a plant over 6 hours, and it's going up. Determine the rate of water loss at 12 o'clock. Use the tangent on figure 10. Give your answer in centimetres cubed per minute and in standard form.
What are you talking about?
Calculate the rate of water loss.
The rate of water loss at 12 o'clock. Use the... What's a tangent?
Look at the figure.
Yeah, it's just a line, isn't it? What am I supposed to do with that? 12 o'clock? 200... I don't know. 202? 212? 200... The rate, though? I don't know. 212 centimetres cubed. Standard form. To the power something that means, isn't it? So let's... I don't know.
Laura, how much water is lost in between 8 o'clock and 2 o'clock?
I don't know.
Look at the fucking graph.
230.
Between 8 o'clock and 2 o'clock.
40.
Roughly.
Yeah?
Yeah. So is the answer at 12 o'clock going to be 202?
32?
You're too
Ish.
stupid for this question. Let's move on.
I don't know what they want me to do, Ron.
No, that's why I'm just saying let's cut our losses. 6.8. Here we go. The rate of water loss at midnight was much lower than at 12 noon. Explain why.
It's cold at midnight.
Is that the main reason that the leaves aren't doing anything? Because it's cold at midnight?
Yeah, it's cold. And there's no sun
and there's no sun.
So there's no photosynthesis, and it's not sweating. And glucose.
All right, now we're on to question 7. Let's go.
I hated everything about those fucking plants.
20 minutes to do question 7, Laura. Figure 11 shows where 3 of the same type of tumour were found in a patient.
I'm glad we're going out on a high.
Big one in the lungs and 2 in the liver. Malignant tumours are cancers. Describe what happens to cells when a tumour forms.
They have rapid, uncontrollable growth.
What evidence is there in figure 11 to suggest that the tumour in the lung is malignant?
It's weird shaped, all jaggedy edges. And big.
Some types of cancer can cause the numbers of blood components in a person's body to fall to a dangerously low level. A person with one of these types of cancers may experience symptoms such as tiredness, frequent infections, bleeding that will not stop after the skin is cut out. Explain how a very low number of blood components in the body can cause these symptoms.
Blood flow reduces tiredness by delivering oxygen to organs and muscles. Therefore, reduced blood components restricts oxygen delivery and increases fatigue.
Okay.
The blood is a key factor in fighting infection within the human immune system. So without enough blood components, infections can't be reached and combated by white blood cells. You can't mute after the fart, Ron.
No, I did that in time.
No, I heard it.
Damn it.
Either that or your noise is not coming in through your microphone.
No, definitely.
I don't actually think it is. Mute.
Hello, can you hear me?
Yeah.
Oh no, really?
Yeah. Yeah, you're not coming in via your mic.
That means we've done this whole thing like that.
I thought it sounded bad.
Why didn't you say?
I did, and you turned the gain down.
But we were fucking with the gain a bunch. We were saying, oh, that's made a difference.
I thought it had. We're not professional
How's
podcast.
this? Does that sound...
Oh my god, Ron, that sounds great.
For fuck's sake.
You sound amazing now. And now we sound professional, Ron.
I'm so cross.
Yeah, you should be more careful.
You did tests.
Yeah. Oh well. Ah.
Come on then. Finish
Okay,
it
so
off.
did I finish the infections one? Yes. Okay. Blood cells are also required to make scabs over cuts and form a barrier to stop more stuff getting into a cut. There we go.
I can't believe my microphone wasn't on.
Why didn't you turn it on, Ron?
Some patients with a very low number of blood cells may be given a blood transfusion. A blood transfusion is where a patient receives blood from a donor. Different groups, different people have different blood groups. Figure 12 shows the red blood cells found in people with different blood groups. The antibodies that can be made by people with different blood groups. Antibodies.
That's why I couldn't hear you when you were whispering to me.
Yeah, can you hear me now?
Yeah.
Okay,
yeah.
that makes a lot of sense now, doesn't it?
Yeah.
Antibodies can bind to antigens that have so we've got blood group A, blood group B,
This
and blood
is great.
group O.
This looks like the sun is being attacked by lots of pitchforks.
Type A antigens are triangular, but type B antigens are square, so they have antibodies for each of these, essentially. That's what you're looking at. Square ones and triangular ones. Lock and key. We all get it. We get it. We're smart. Antibodies can bind to antigens that have complementary shapes. When antibodies bind to the antigens on the red blood cells, many red blood cells begin to clump together. Each red blood cell is about 8 micrometers in diameter. Many capillaries have an internal diameter of 10 micrometers. In one type of blood transfusion, only red blood cells from a donor are transferred to the patient. It is dangerous for a patient with blood group A to receive red blood cells from donor with blood group B. Explain why.
They don't fit in the veins? Capillaries? I don't know.
14 minutes.
Doesn't mesh well with, I don't know.
Giving up?
Yeah, I don't know.
They don't fit in the capillaries. It doesn't mesh well. Explain why blood group O, red blood cells, can be given to patients with any blood group.
Because they don't have any antigens on the outside.
Yes.
What are Wait, hang on. Go back to the last question. If you put blood group B into a blood group A person, then their red blood cells will fight their antibodies.
Is
'Cause
that
they
the
fit together
language you
in-
want to use?
I don't know, Ron.
Are they going to fight?
Lock and key together. Cancel each other out. I don't know what they're doing to each other. Healing each other.
Why don't you read the information that's on the page before?
They'll bind together.
Why?
I can't really read the lines. I just see the words.
You look ill.
Yeah, I feel ill. I'm so hungry and tired and sad and dispirited, and I've had to listen to so much farting that you thought I couldn't hear. And
I only farted 3 times.
I heard them all.
I thought I was muting.
It's like an Agatha Christie, isn't it? The fart that made us realise our big mistake. If not for that fart, Ron, it would still be an echoey cavern.
Yeah, is the echo gone now?
Yeah, it sounds amazing now. You sound like you're in a padded podcasting studio, not in a basement.
Fuck's sake.
What's the next question then?
Are you not finishing that one?
Did we not? I thought I had finished
No,
it.
you got halfway through it.
Which question?
I asked you to read the information. You
I
said
said because they're bind together.
You said I can't read the information.
I said they're bind together.
Can't read the lines. I just see the words.
I said they were bind
And then you said
together.
their red blood cells will. Their red blood. You said their red blood will bind together, and I said why? With what? And then you started talking about farting.
With the antigens. The blood cells will bind to the antigens.
Is that all you want to say?
Yeah.
Okay, right. Question number 5. Explain why blood group O red blood cells can be.
Don't have any binders on the outside.
Oh, we've done that one. We've done that one. Oh, have we skipped a question somewhere? No, it's all fine. It's all fine, guys. It's all fine. It's all actually. It's all fine. Sounds like they're having fun downstairs.
Bad game.
Table 4 shows some of the risks associated with blood transfusions. We've got allergic reaction, hepatitis B infection, hepatitis C infection, and kidney damage. Which risk has the lowest probability of occurring?
So we've got 0.9%, 1 in 3 times 10 to the power 5, 6.7 times 10 to the minus 7, or 1 in 70,000. Hepatitis B, I don't know.
Okay. Laura, last question. A person has a tumour blocking the tube leading from the gallbladder to the small intestine. Explain why this person would have difficulty digesting fat.
They're obsessed with fat. I don't know. Tumour gets in the way of the fat moving about, restricts the blood flow to the small intestine, so the villi can't digest the fat.
And we're done.
I haven't finished.
There is no point in you finishing that. No point at all. Let's not pretend there is.
That was horrible.
Oh my goodness.
That was horrible for so many reasons.
Laura, we've got to do chemistry and physics next.
Yeah. Not for at least a week.
Yeah.
Jesus Christ.
And that was it. That was the episode. You just listened to it. What did you think? Let us know. Let us know on social media. Let us know on, I guess, via email. Let us know in the street. If you see us, if it's nice. You say mean things on the internet, but be nice on the street. Be nice on the street to everyone, I guess, not just us. Be nice on the internet to everyone. You can be a bit mean to us on the internet, but just a bit. Tune in next week to find out how Laura did. We've marked it now, so I know how she did. Laura knows how, but you don't. So why don't you tune in next week and find that out? Join us on the Patreon. That's a super fun time. We've just done an episode on Interstellar. Bamboos and Laura well, Laura was a bit too thick to understand it. She didn't understand it. So it was a good episode though. Buoyancy, Class Clown, Minecraft. Just lots of good stuff on there. We did a board games episode, books episode. Right, Gnocchi's about to go start scratching a door because it's closed. So I'm gonna go. But love you guys. I hope you enjoyed the app. Without Laura here, it's really hard to know if I say class dismissed now or if I say that later. So I'm gonna cover my bases and just say now, class dismissed.